let's start the class. Good afternoon guys, welcome to NEET WORLD Institute and NEET WORLD YouTube channel. And yes, today's class is for class 11th IPE guys in physics. That is gravitation lesson we are going to concentrate. In gravitation lesson we will get short answer questions, that is of 4 marks, right? And before that let me introduce one thing. Our NEET WORLD Institute has designed the IPE material exclusively for Telangana and AP students of physics, chemistry, maths, botany and zoology, right? So you can give a hi message to our YouTube channel, or else you can download a MedWorld app which is in Play Store, and right, you can give a hi message in a chat box. You will get a soft copy of the material. Okay, yes. So now let's go into the topic, that is gravitation, right? So in this gravitation, the first question which we are going to see is state Kepler's law of planetary motion. So whenever you are getting a Kepler's law, okay, when you are seeing the Kepler's law, we are having 3 laws. Okay, so let us focus on one by one laws. Okay, so the first law, it is Kepler's first law, okay, which is nothing but law of orbit, we will say, right? So all planet moves in around the sun in elliptical orbit, right, when with the sun at this one of the focus. Okay, so what is the first law says? Whatever planet we are taking which will be surrounding or goes around in the elliptical path around the sun, right? That's the first law, that is called as law of orbit, we will say. So all planets move around the sun in elliptical orbit with the sun at one of this focus. Sun is one of the focus and the planet will be surrounding. Okay, so when I talk about this is focus 2, when I take this is my major axis, okay, major axis, and this is my minor axis. When I talk about semi-major axis, half of the major axis, no, that is semi-major. So half of the semi-major, no, is focus, we will say. Half of the major is semi-major, half of the semi-major is that focus point, we will say. This is one focus point, again this one more focus point, right? This is the first law, right? When we go for the next one, Kepler's second law. So it is law of areas, we will say. Okay, so first before going into the definition, we will see the diagram over here. Let me take the point A and point B. Okay, let me show in the diagrammatic view. Okay, right. So when I talk about the point A and point B, no, at point A the planet was initial, that is at time t is equals to 0, let me take, okay, and at point B planet was at time t is equals to t1, let me take t1. Okay, so it has been covered some distance, right? It has been covered some distance. When I talk about the sun, which is situated at one focus, from the sun to the first t is equals to 0, let me take the point, okay, let me take the line. And when I talk about the sun and the second point B, I have drawn a line. When I see it has been covered some area, no, this area we will keep as it is, this as A1, okay, and this is near to the sun. When I take a point which is away from the sun, no, and this is my initial planet at time t1, so t is equals to, okay, t is equals to 0, and this is the planet at time t is equals to t1. Okay, now if you take the same method, no, I will get the area. So this is my area 2, let me take, okay, area 2. So area 1 sorry, which is near to the sun, right? No, the planet is near to the sun. When I talk about area 2, which is far away from the sun, right? So when I talk about area 1 and 2, like both are like one is near, one is far, okay, both are not in the same points, it has different points, but the thing is, when I talk about area 1 and area 2, they are equal. This is the thing which are explained in Kepler's second law, okay, law of areas. Now we will come to the point. So when we talk about the second law, the line which is joining the sun and the planet, which sweeps equal area in equal interval of time. Equal area, A1 and A2 are equal interval of time, T0 to T1, 0 to T1, right? So this law is called as law of area. Understood the point? So when we are explaining the definition, try to inject some words also, like A1, A2, and A1 is equals to A2, and if you draw some diagram, no, it will be easy to analyze what the examiner is correcting, okay. Fine, this is about the second law. Can we go for the next one, third law? Can we go for the third law? Completed? Okay. So the next one is Kepler's third law. So what Kepler's third law says is, so it is law of periods, we'll say. First one is law of orbit, second one is law of areas, third one is law of periods, okay. If you keep remember this 3 points, it's enough and we can elaborate the sentence, right. So here what is the thing is, the square of a time period, okay, t square of a revolution of a planet is proportional to the cube of the semi-major axis. Let me take what is the semi-major and major axis, what is minor axis. First of all, let me tell you here. So if I draw this as a elliptical path, okay, consider this as a ellipse, okay. If I talk this diameter and this diameter, both are not equal, right, both are different. This one is small and this one is big, and the big thing is called as major axis, we will say major axis, and the small one is called as minor axis. Major axis and minor axis. Now when I talk about the major axis, off of the, okay, off this off is there, no, this is called as semi-major, we will say semi-major axis, and half of this is called as semi-minor axis, we will say, okay. Now you got cleared about the what is major axis, what is minor axis. Now we can use that thing here. So the square of time period t square of the revolution of a planet is proportional to the cube of the semi-major axis. So t square is directly proportional to r cube, or else we can say t is equals to, yes, it is r power 3 by 2 also we can say, or else we can, it is nothing but root r the power 3 we can say, no, like when I take the square to the other side, it is, yes, okay, easy, no. So t square power r, so t square directly proportional to r cube, right. This is about the third law. Then can we go for the next one? completed? Okay guys, we'll go for the next one. Okay, so what is the next one? Yeah, this is the diagram for the previous thing. Okay, third law, and this is major axis, semi major axis, and this is semi minor axis. Okay, now what is the question they have given? First of all, derive the relation between acceleration due to gravity at the surface of the planet and the gravitational constant. Okay, read the question once more if you are not getting. Derive the relation between acceleration due to gravity, that is small g, at the surface of a planet and gravitational constant capital G. Okay, let's go into the derivation now. So I need a relation between small g and capital G. What is small g? It is acceleration due to gravity. Okay, both are different guys. Capital G is nothing but gravitational constant. Okay, it is gravitational constant, it is acceleration due to gravity. Okay, we know that one force, that is mass into acceleration, no, right? So what is force? It is either push or pull, right? This is the thing we have learned in the lower classes, but when we talk about in the formula type, F is equals to mass into acceleration. When I talk about acceleration due to gravity we are talking, no, so can I consider this as F is equals to mg, F is equals to mg. And in gravitational lesson we have talked about one more force, that is F is equals to g m1 m2 by r square, no, right? No, so can I write that F is equals to g capital M small m by r square, right? So let me consider this as equation 1, equation 2. From equation 1 and 2 we can write that as F is equals to, okay, this is mg is equals to g capital M small m by r square. From here m and m will get cancelled, g will be equals to g m by r square. So let us write what are the terms are given. G is nothing but gravity, right, gravity, and G is capital G is nothing but gravitational constant. And what about m? M is nothing but mass of the earth. We are talking about the surface, no, mass of the earth. And r is nothing but radius of the earth. So we know the approximate value of mass, radius and gravitational constant, right? So finally we have got from this equation only the value as g is equals to 9.8 meter per second square, right? Have you understood now how we have got that value 9.8 meter per second square, and in some problem we will use g is approximately to 10 meter per second square also for calculation purpose, right? So this is about the derivation of the second question. Done. Can we go for the next question? Okay. So if you see here, we got that value as G is equals to Gm by R square, right? So this is the relation between G and small g and capital G, which is applicable for any planet. Okay. Now the next question is, how does the acceleration due to gravity changes for same value of height and depth also? Okay. So I will give a short diagram explanation of this question so that it will be easy to understand the concept, right? So when I talk about, this is my planet, right? At the surface, at the surface means the gravity is G is equals to 9.8 meter per second square, which value which we have got in the previous question. Now the thing is, we have taken the particle to the height h, Now what is the gravity? Will it be same or will it be different? Obviously it will be different. And the same thing, when I take the particle to the depth d, again it will be different. So we need to find what is the gravity at height h, and we need to find what is the gravity at depth d. Both we need to get it. So for that, for smaller height, we have taken for smaller height, okay, variation of G with height h. So the formula is GH will be like gravity at height h will be equals to, what is the G? It is normal G, that is 9.8 meter per second square only. It is 9.8 meter per second square, okay, into 1 minus 2h by r. What is h? The height of the object, which is taken from earth surface or any planet surface, okay. And what is r? It is radius of the earth, radius of the planet. This is the thing, understood? Now this equation is valid for h is less than r by 2, okay, h is less than r by 2. Now variation of G with depth d, we have taken to the depth now. Height is G into 1 minus 2h by r, that too it is valid for h is less than r by 2. If r is 6, okay, r is 6, for example 6 meter we will take, or 6 kilometer. So if I take h as 2 kilometer, the formula is applicable. When I take h as 4 kilometer, it is not applicable, because when I talk about the value of r, it is 6 kilometer and divide by 2, which is nothing but 3 kilometer. Either it should be below 3 or below 3 only. If it cross 3 or more than 3, no, it is not applicable for this condition. That condition we will see separately, okay. And now the depth d, gravity at depth d will be nothing but G into 1 minus d by r, where this G is nothing but 9.8 meter per second square only, and d is nothing but depth, and r is the radius. Okay, this is about the first point, smaller height and smaller depth, okay. Yes, you can take a note of this. We can go for the next point. Done? Okay. So if you see, for a larger height, okay, larger height in the sense, what is the thing? We can say that it is greater than the radius, okay. When h is greater than r, the formula is GH gravity at height h will be equals to g into r by r plus h the whole square. Suppose if r is equals to h, what happens? Our depth is equals to h. Depth is equals to h. What happens here? Depth is equals to h in the sense we can take this as gh will be equals to g into r by r plus r, no, r plus r into whole square, which is nothing but this g into r by 2r, r will get cancelled, which is g by 4, right. Now depth g into 1 minus d by r, when d is equal to h, it is 0, g is equal to, like d is equal to h in the sense g by 4. Okay, so this is the condition. Okay, this is the condition for larger heights. I hope you got it right. Abhishek sir, please explain again. So which question, Abhishek? Let me show the question numbers, and which question you want to explain me again. So we have seen 3 questions, right? One is Kepler's law, and yeah, this is first question. Okay, Kepler's law, and second question is we need to derive the equation between g, capital G and small g, and the third question is we have to show what is the g, like gravity for height h and depth d. Okay, so which question you need to explain me? So which question, Abhishek? Yeah, you can give question number in the comment section. I can see the question number and I will explain you the question. Okay. Yeah. So the next question, if you see here, it is what is orbital velocity, and I need to obtain an expression for it. Okay. So orbital velocity is nothing but, see, let me give in a diagrammatic point of view. Okay. When I talk about when I talk about a planet, okay, when I talk about a planet, so gravity is there, and when I talk about a force, gravitational force also is there, and the thing is how the satellites are like revolving around the earth. And if you see about what about a moon, no, this also revolves in a circular path or elliptical path in the around the planet, right? Whatever planet it can be any planets. Okay. Now if you see that because of the gravity only, like the force, gravitational force only, it is trying to revolving, right? Now similarly when we are sending the satellites, it also rotates in the circular path, right? Yeah, when I take this is my orbit, which is for the satellite. Okay, yes, and this is for the planet P. So this is my radius r and this is my height h. We have taken to height h. No, this is the thing. Now we go for the orbital velocity. What is the meaning of that? The velocity to be given to a body in order to revolve. So we need to have some minimum velocity to revolve around the planets, right? That velocity is called as orbital velocity. Okay, in a circular orbit is known as orbital velocity. Now the thing we need to find is, okay, we need to find what is the velocity, right? That one we need to derive now. So consider a satellite of mass m revolving around the earth at height h. That's the thing we have drawn here. Now if we talk about a force is nothing but, we know that gravitational force is nothing but it is F is equals to G mm by r square, right? But when I talk about orbital, no, like we have taken to height h, so force will be equals to G m by r plus h the whole square, Am I correct? We have talked about this planet only force, but when we are talking about the orbital force, this is gmm by r plus hd whole square, because this is radius r and this is height h, right? And when we talk about centripetal force is helping me to revolve, no? Revolve. What is centripetal force? mv by r square, mv by r, no, not r square, mv by r. So mv by r right now, but when we talk about an orbital, it is r plus h, so this is one equation, and f is equals to, let me take, f is equals to mv square by r plus h. So this is second equation. When we equate both the things, what happens here? M and M will get cancelled, and this one time and this one time will get cancelled. Okay, so remaining v square will be equals to gm by r plus h, right? So what happens here? V will be equals to root over g m by r plus h, right? Gm by r plus h. This is about the velocity, orbital velocity. Okay, so if the acceleration due to gravity is g at height h, what happens? So what happens here? G is equals to gm by r plus h the whole square, right? Gm by r plus h will be equals to g into r plus h. How we are taking this? We know that gm by r plus h the whole square, right? So this one we have got from gravity, gm by r square, right? That one we have substituted here, right? That one we have substituted here. So finally, instead of this gm by r plus h, we can replace in terms of g. Okay, how we can replace it means, let me explain that. Yeah, so we know that g is equals to this is gm by r square. This one we have got in the second equation, so second question, right? Similarly, g will be equals to gm by r plus h the whole square, right? So can I take this equation here? V is equals to root over gm by r plus h. So can I multiply this in r plus h by r plus h? What happens here? It is root over gm by r plus h the whole square into r plus h. Is this looking similar to g? Yes. So v will be equals to root over g into r plus h. That's it. That's the value of orbital velocity in terms of g. Okay, in terms of g. Now if the satellite is very close to earth, so we can neglect this h, that is h is approximately equals to 0, and orbital velocity will be 7.92 km per second. Okay, we know the value of g, we know the value of r. When we multiply and take under root, we will get 7.92, which is approximately 8. Right? Excuse me. Done? Done? Yeah. Yeah. So the next question is, what is escape velocity? Okay. So escape velocity is nothing but, by the term itself we can say like it's escaping from somewhere. Okay. That is not anywhere, it's from the earth surface only. The minimum velocity required by a body to escape from the gravitational influence of the earth is called as escape velocity. Okay, so we need to find expression for this also. So we know that gravitational potential is nothing but V is equals to minus gm by r, right? And potential energy is U is equals to minus gmm by r. And what about the kinetic energy? It is half mv square. So when we talk about these equations, no, and we have if we equate that equations, Here m and m will get cancelled, so velocity, orbital velocity, sorry, escape velocity will be equals to root over 2 gm by r. So for orbital velocity, what is the value? It is 8 km per second approximately, and for escape velocity it is 11.2 km per second approximately. Okay, this is about the escape velocity, right? So the next one is, what is geostationary satellite, and we need to state what is the use of that, right? So geostationary satellite, a satellite whose time period of a revolution is equal to the time period of rotation of the earth is called as geostationary satellite. I will repeat the sentence: a satellite whose time period of revolution is equal to the time period of rotation of the earth is called as geostationary satellite, and this satellite appears to be at rest with respect to earth. With respect to earth, no, obviously it will be in rest because both are going in the same velocity, right? So uses to study the upper region of the atmosphere, to study the change in atmosphere, to know the shape and size of the earth, and fourth point is to identify the minerals and natural resources present inside the earth's surface, and to transmit the TV program and the distance places, and finally to study the primary cosmic rays. So these are the points, but you can write your own points also, whatever you know about the satellites. Okay, so this is about gravitational lesson, and with this we have ended the short answer questions of this lesson. Okay, I hope it's cleared, right? So you can take a look of this, and finally I'll inform once again. So you download NEET app and give a hi message in the chat box, so you can get your soft copy of the material of this class 11th IP or else class 12th IP of physics, chemistry, botany or zoology or mathematics 1A, 1B or 2A, 2B also, right? Yes, so with this I'll end up the session, guys. Thank you. We'll meet in the next class.